Refresh your memory, the title of the lesson was Linear, Exponential, and Quadratic Functions, and we have done linear, we've done quadratic. These are quadratic, there are parabolas. And now we're going to do exponential, and they're a little bit more intricate and detailed and harder to deal with. So the whole second difference and first difference thing, that's not going to work here. That's not an issue on exponential. It's not a polynomial. So here goes. I'm actually going to start at the bottom of this, and trust me, it's going to work. It's going to work quite nicely. So if I start at the bottom, then we'll notice the pattern and we'll actually be able to fill in at the top. So I'm going to start down here at 3. And what I'm going to do is, I don't have a graph to go by. I'm going to have to create the graph this time. And when I do that, I'm going to need to use this equation which they gave me. So they're going to give me an x and I plug it in and find a y. So 3 is x. So what I really have is 1 times 2 to the third power. Okay, so, well, 1 is just 1 times whatever, so that 1 really doesn't mean much. But 2 to the third would be 2 times 2 times 2. I have 3 of them. 2 times 2 is 4, times 2 is 8. So this is 8. And I'm going to come over here in red, just for dramatic emphasis, and I'm going to plot the point 3, comma 8. So here goes. 3, 8 is right there. Okay, there's our first dot. Okay, let's plot the next one. This is 1 and then 2 to the second. Well, 1 times 2 to the second, 2 times 2 is just 2 2's, so it's 4. So we'll come over here and we will plot the coordinate 2, 4. So 2, 1, 2, 3, 4. There's 2, 4. Now, don't be like, oh, let's draw a line. It's not a line, okay? It's not a line, trust me. Okay, this next one is 1 times 2 to the 1. I hope you realize what I'm doing. I'm taking the x values and I'm plugging them in right here and just cranking out an answer. So 1 times 2 to the 1. Well, 2 to the 1 is 2 times 1 is just 2. So the coordinate 1, 2 is going to get plotted over here. So I go 1, comma 2. There we go. And I hope you know what's kind of happening here. Let's notice a pattern. If I was to just slide up this way, just like go straight up, I'd be like 8, 4, 2, and I'm looking at the pattern. 8 turned into 4, 4 turned into 2. What are we doing? How do you turn an 8 into a 4? Well, you can subtract 4. Okay, great. Yeah, but what else? How do I turn an 8 into a 4? I could take half of it. I could take half of that. I could take half of that and half of that and half of that, and I could keep taking half as I move up, and it works. Okay, let me go ahead and tell you the next answer. And the next answer is 1, because I take half of 8 and I get 4, take half of 4 and I get 2, take half of 2 and I get 1. And if I wrote it out, I have 1 times 2 to the 0. Well, 2 to the 0 is 1. Anything to the 0 power is 1, except 0 itself. So if you need a visual for it, here goes. 1 times 2 to the 0 power, and I get 1. There you go. So I'm going to plot the point 0, 1, and I want to just point out something very quickly right here about exponential functions that's going to kind of come in handy later on. That 1 right there, that's my x-intercept. I'm sorry, my y-intercept. See? 1. 1. Trust me. See, on the next one, we're going to be like, oh, look, I have a y-intercept at 4. All right, here goes. We're going to plug in a -1 right there. And now things get a little bit tricky, and we have to go back to math 1 for a second. So 2 and then -1. If I have a negative exponent, it moves my entire factor down to the denominator. So what I really have is 1 times 2 to the -1. Okay, don't panic if you haven't seen this in a while, but this is one big fraction. And there's a 1. This fraction is one big numerator. 2 to the -1 is really that. And when I move this down to the denominator, the exponent becomes positive, and 1 over 2 is it's a half. So really, don't panic. If what I said didn't make too much sense, then you could continue to look at the pattern and say, 8, half of that is 4, half of that is 2, half of that is 1. Half of 1 is a half. Half of a half is 1/4, And I could do the same idea here, same little bag of tricks I just did if you wanted to. And you could be like 1 times 2 to the negative 2. Oh, this is one big numerator, but this negative exponent moves things to the denominator. This 1 doesn't move because it doesn't have a negative exponent, but this 2 moves down. 2 squared is 4, so I have 1/4. All right, let's plot these points. Negative 1, comma 1/2, negative 2, comma 1/4. In case you care, this one's going to be 1/8. And if I was to connect these, I would have an exponential curve. The word exponential is used a lot in other contexts as well. Like, wow, the economy is improving exponentially. It means it's getting real good real fast, okay? That's what it really means. So let me take this idea and review a little bit of Math 1 with you here. So this was my y-intercept. And this is what I was growing by. Now, I know I was like, I'm taking half, I'm taking half, I'm taking half, I'm taking half. Yeah, I was going backwards. But if I was to move forward, I'd double it, I'd double it, I'd double it, I'd double it, I'd double it. I'm doubling it, okay? So this is my growth factor. And you might be like, growth, how do I know it's growing? Well, look at the graph. It's going up, right? The next one's not going to go up. The next one's going to go down. And we're not going to have a growth factor. We're going to have a decay factor. Okay, so let's do it. We're going to plug these values in here, and when we do, I think it would benefit us to start using the calculator just a little bit, so let's do it. Let's press y equals, and if you have anything in there, clear it out. And we're going to type that, exactly that. So 4 and then 1/2, I'm going to use 0.5, to the x power. So 4 times 1/2 to the x power. And I want to know the y values that are outputs when I plug in these for inputs. So let's do it. I'm going to go to the table, and you might have this, or you might not, or you might have nothing, or you might have a smattering of random stuff. So let me just get us all on the same page here. Second and table set. I hope you saw where my fingers were. I went second and table set. And just so we're all on the same page, let's set the table to start at 0. This little triangle table, it means delta table. It's a Greek letter. It represents change. So how much is my table changing? Well, I'm going up by 1 every time. And let's set independent to auto. Sorry, I mispronounced it. I called it auto. Second and table. And now I have the values that I need to have, right? Now, I don't have the negative 1. We can scroll up for that. I pressed second table, and I've got this. So now I can just fill in the values, right? So negative 1 gives me a value of 8. And then a 0 gives me a value of 4. And then 1 gives me a value of 2. And then 2 gives me a value of 1. And then I'm going to set this aside because I know the pattern. And I'm going to go ahead and write some stuff, even though you know the next one was 0.5, and you were probably ahead of me on that, and that's fine. Here's what I know. This is my y-intercept. It's at 4. When I plug in 0, I'll get 4. If I plotted this, I'd have 0, 4. Boom, right there. Okay, this 1/2 right here, I'd say, oh, what's my growth factor? Well, if it's a half, it's not growing. It's getting smaller. And so when I plot these other points, you'll see this graph doesn't go up, it goes down. And it's going to be called a decay factor, not a growth factor. So let's keep plotting points. Negative 1/8 is here. 1, 2 is here. 2, 1 is here. And if I looked at this pattern and did not have my calculator, I could say, oh, well, I'm just taking half of everything every time. Half of the previous every time. Half of 8 is 4. Half of 4 is 2. Half of 2 is 1. Half of 1 is, well, it's a half. So 3, 1/2 is right there. And so if I connected them, It'd be like that. So exponential functions are curvy, clearly not linear, and they are not like quadratics because they don't go up and come back down or go down and come back up. And they have a very different structure to their equation as well.